morning, Westchester mathematicians. This is the video for Wednesday, April 8th. Our lesson today is on box and whisker plots. Our objective for today is to be able to create and interpret box and whisker plots. You may remember from chapter 9 that mean, median, and mode are measures of center, and we discussed that range was a measure of variability. Well, a box and whisker plot will show the variability of a data set. The things that you need to know in order to construct, things that you need to have in order to construct a box and whisker plot are part of what they call the 5-number summary. When you have your list of data, as always with our whether it's a histogram or a stem and leaf plot or whatever, you need your data ordered from least to greatest. And the 5 numbers that you will need to know in order to make a box and whisker plot are the least value, which means the lowest or smallest or first number on your list, the greatest value, obviously the largest one on your list, quartile 1, quartile 3, and the median. Now quartile 1 and quartile 3 I know were new as of this year, but we did discuss them in 9.4. You might want to review back or refer back to 9.4 on quartile 1 and quartile 3, but I'm also going to do a quick review of it here. Let me just show you real quick. This squiggly line that I have running through here is supposed to represent a long list of numbers. And in 9.4, what we learned was that if you find the median of the entire list of numbers, that breaks your list, your data set, into a lower half and an upper half. And then when you find the median of the lower half, that is your quartile 1. And when you find the median of the upper half, that is your quartile 3. So we learned how to do exactly this in lesson 9.4 before school let out. So there are 3 of your 5 numbers that you need: quartile 1, quartile 3, and then the overall median of the entire set. And then the other 2 numbers that you need from the 5-number summary would just be your least number and your greatest number. Again, remember this squiggly line just represents a long list of numbers. So you'll, when you put your data in order, right off the bat, you've got your least number and your greatest number. Then you find the median of the data, that's another thing you need, and then you find the median of the lower half and the median upper half. Those are your 5 numbers that you're going to need to make your box and whisker plot. And the last thing I want to show you is, and we talked about this during lesson 9.4, once you have your long list of data and you find the median of the whole list and then the median of the upper half and median of the lower half, you're basically breaking your data into approximately 4 equal chunks. It may not be exactly 1/4, 1/4, 1/4, and 1/4, depending on how many values you're in your data set, but it approximately breaks it into fourths. So the other thing that was new in 9.4 that we talked about, but it will come up again in this lesson, is interquartile range. The interquartile range is the difference between your 3rd quartile and your 1st quartile. The regular range that you remember from 5th grade is your highest number on your list minus your lowest number. And remember, interquartile range is this higher quartile minus this lower quartile. But what that will give you then is where half or 50% of your data falls, because if 1/4 will fall before the 1st quartile, 1/4 will fall after the 1st or the 3rd quartile, and then 2/4 or 1/2 will fall in between the quartiles. The top half of this picture now is what I was just showing you a second ago, which is what it looked like in lesson 9.4 as far as how the data are distributed when you just have a long list of data values in order from least to greatest and you divide them into the quartiles. The bottom is what it would look like on a box and whisker plot. You can see the 5 numbers from the 5-number summary that are used to make the box and whisker, which is your least and greatest values, your quartile 1 and quartile 3, and your median. And you can see from both pictures how 1/4 of the data is below or to the left of quartile 1, 1/4 of it is above or to the right of quartile 3, and that 2/4 or half are between quartile 1 and quartile 3. Okay, in order to construct a box and whisker plot, First of all, again, you need your data values in order from least to greatest, as always. And then you need a number line that includes every number from your least to your greatest. You absolutely cannot make a number line that only includes these 10 numbers. It has to include, just like on the number lines for the dot plots, and just like with our histograms and our stem and leaf plots, you know, you will see where any gaps are. You have to include every number on the number line. So now I'm counting by twos here, but I'm going from 10 all the way to 44, which is going to include every number in here. And in between the spaces would be the odd numbers if we have them, which we do have a few. So you need a number line, but you don't actually make the box and whisker plot on the number line. You make it above the number line. And the first thing to do is we're going to need to find our 5-number summary. Now, our least value and our greatest value is easy. That's obvious. There they are right there, right off the bat. We need the median of the entire data set. So remember, you want to count in from the outside. Okay, we have 2 numbers left. Hopefully you guys remember from last year and earlier this year that in order to find the median when there's 2 numbers, you add them together and divide by 2, or you find what's right in the middle, which in this case would be the number 30. But if you add 20 and 30, you get 60 divided by 2, you get 30. So that's our median. And then next thing we need is our quartiles. We now have 5 numbers. We need to find the median of these 5 numbers for our lower half. That would be this number right here. And the median of these 5 numbers for the upper half would be this number right here. So there's the 5 numbers we need for the 5-number summary. Least value, quarter 1, median, quartile 3, and greatest value. Now, you're going to want to put a dot above your number line at all of these numbers. 11 is going to be between 10 and 12, so I'm going to put a dot there. 21 is going to be between 20 and 22, so I'm going to put a dot there. 30 is right here. 37 is between these, and 40 is right there. All right. From your least and your greatest into the next dot, these are your whiskers. So your least value to quartile 1 is a whisker, and your greatest value to quartile 3 is a whisker. Now in between here is where you draw the box. In between quartile 1 and quartile 3. And remember, this is quartile 1, 21. This is quartile 3, 37. And then for the median, then you just draw a line right there where the median, which is at 30. So these 3 end up being lines rather than dots, but I like to just start with a dot just to frame out your box and whisker. So again, it's obvious why it's called a box and whisker. Here's the box, here's the whiskers. And again, this is showing you the range of your data set here, of your values. 1/4 of them, the lower 1/4 are stretched out pretty far here. There's a big range in the lower 1/4 of the data. The range of the upper 1/4 is a lot smaller. And then your middle, the middle chunk, the middle range, this would be your interquartile range between quartile 3 and quartile 1. This is going to be between 21 and 37. All right, as always, our videographer is Mr. Doolin, and he called to my attention that the greatest value here was 42, not 40. When I made this initially, I made that wrong. Hopefully some of you guys caught it, but Mr. Doolin caught it. Say hi, Mr. Doolin.
Hello, it's me.
All right, we're going to do another example, but I just need to switch the board. Okay, I just wanted to show you one more quick example. I'm going to use the same number line, but it's a different set of data values. I'm going to go through this one quicker. You can pause and rewind any of this at any time, or freeze it, or whatever you need to do. On this set of data, obviously 15 is your least number, 42 is your greatest number. You work your way in. The median is 29. Now remember, if there's only one number for your median instead of 2, like the last example, then that number is not included in either the upper half or the lower half. So my lower half is only 3 numbers and my upper half is only 3 numbers. So those makes the medians easy to find. The median of the lower half, which is quartile 1, would be that, and the median of the upper half, which is quartile 3, would be that. So I'm going to put my dots, my 5-number summary right here. 1 dot at 15, which is my least value. 1 dot at 18, which is my quartile 1. 1 dot at 29, which is over here, is my median. 1 dot at 40, which is my quartile 3. And 1 dot at 42, which is my greatest value. Again, the least and greatest values go into quartile 1 and quartile 3 to make your whiskers. And then the box goes between quartile 1 and quartile 3 with a line where the median is. So even though we're using the same number line here, it's a different set of data values. It's a totally different looking box and whisker plot. You know, the range for the lower quarter, it's the fact that there's a small number of data values is why this looks different too. So our range of our upper and lower quarter of data value here are, you know, there's pretty small, and there's a big range. As you can see, there's a big range between the middle half of the numbers. That's our interquartile range. Remember, the box represents the interquartile range, and the greatest value minus the lowest value would be your regular range. The picture here is from the top of page 462 in your book. Just as in Monday's lesson where we talked about the shapes of dot plots and histograms, you can also describe the shapes of box and whisker plots. With the dot plots and the histograms on Monday, we talked about the tail, and we said it was skewed whichever way the tail went. With box and whisker plots, we're talking basically about, instead of a tail, whichever whisker is longer. If the left whisker is longer, then it's skewed left. If the right whisker is longer, then it's skewed right. And if it looks pretty even, then it is, we just say that it is symmetric. The last picture I want to look at is from the bottom of page 462 in your book, to where they show you a double box and whisker plot. This particular one represents lifespans of crocodiles and alligators at a specific zoo. You can and will be on homework or tests in the future asked a lot of different types of questions about interpreting things like this, pictures like this. In this particular example, if we're talking the shapes, the crocodile, the left whisker is longer, which means it is skewed left. For the alligator, it's symmetric. Notice that as far as the ages, the range of lifespan on a crocodile is much longer, a much larger range than the alligator. It's from 45 to 80 for the crocodile, which is 35 years. For the alligator, it's from 40 to 60, which is only 20 years. Also, you can see that the median, remember that's the vertical line inside the box. For the crocodile, the median age is 70. For the alligator, it's 50. And in all box and whisker plots, remember that 1/4 of the data is located on each whisker, and half of the data is located inside the box. The box is your interquartile range. So again, on this particular example, the interquartile range of the crocodile is much larger than that of the alligator. For the crocodile, it's between 55 and 75. For the alligator, it's between 45 and 55. All right. I think that's going to do it. Unless we, just maybe have a real quick close at the end. Okay, that does it for box and whisker plots. Make sure you email your teachers if you have any questions. And please get those assignments done. Unfortunately, we're going to be doing this way the rest of the year, and the assignments are just going to keep piling up. If you don't do them, please get them done and stay caught up. Have a good day.